We're going to look briefly at computer intelligence here and what it means, at least when we're going to talk about it in this class, when we describe something as intelligent. So to jump into that here, first we want to talk about intelligence. And so we're looking at artificial intelligence specifically here because it's not a natural intelligence. It's not something that just exists naturally in the world. It's something that is made or programmed or created. There's not one fixed definition for artificial intelligence, so we're going to pick one for this class. And so for this class, what we mean by intelligence or artificial intelligence is the ability to make choices in pursuit of a goal. So that doesn't necessarily mean that they're making good choices or that, that it's very successful. Or that goal is hard to achieve. The point is that there is some sort of choice being involved. It's choosing one thing or the other, and that is informed by some set of rules or idea of it trying to reach some goal or some end state. And so because of this, many things can be considered intelligent. The two examples in the videos you would have seen before this both of them videos, one of them video, one of them the intelligent paper, we would consider those artificially intelligent by our definition. So the goal is to win their respective games, and each system, based on the way that the game is currently, it makes a choice. It says, I want to put an X here, or I want to take this many marbles. So it's making a choice pursuing that goal. And you can see in the two examples the varying degrees of success or failure of that. So we also need to define this last word here, algorithm. That's going to come up a lot. And an algorithm is not necessarily just with computers, but what we mean by an algorithm is it's a set of instructions or steps, usually with conditions to guide those choices or actions. So you've used algorithms before, obviously with computers and stuff like that, but you've also, if you've learned how to multiply two numbers, right? If you have like 37 times 130, and you've done something like this before, 0, then 1, carry 2, 3 times 3 is 9, plus the 2 gives you 11, carry the 1. If you've done this before, this is an algorithm. It's a set of instructions, right? Take the first number, multiply it by the first number above it. Take the first number, multiply it by the second number, etc. So that's a set of instructions. So you used algorithms a lot in math. When it comes to talking about artificial intelligence, though, it's that those instructions tell the computer or the paper or whatever what decision to make. And in order to pursue some goal, these conditions are critical. So it looks at the conditions, it looks at information given to it, and then it makes a decision based off of that, and then it uses those to guide that action or decision. So when we talk about intelligence in computers, we are really talking mainly about these algorithms. And there's three types of algorithms that I want you to be aware of in this unit. The first are traditionally programmed AI. And this is, if you've played video games, if you talk about like an AI, like a computer player, they're a traditionally programmed AI. If you talk about older computer programs that do certain things or solve problems, those are traditionally programmed AI. And a traditionally programmed AI has instructions like that tic-tac-toe game or like the Dr. Nim game. It says, if these are the conditions, take this step. If this is what you're seeing, take this step. So everything is kind of explained out step by step for it. And traditionally programmed AI, we know, like we can predict what they should do because we know and we've planned out and mapped out exactly how it works. Genetically bred and neural networks are a little bit different because these are going to have kind of why they're doing what they're doing gets obscured a bit. We can kind of understand big picture bits and chunks of it, but ultimately these are both more unknowable because basically we're just saying keep tweaking the program until it does what we want it to. And we're just having it tweak it randomly and make lots of changes until it works out well. And we'll talk more about these tomorrow, but I just want to kind of have you keep those in mind. That these are somewhat more unknowable in that we can't explain exactly how they work. We can definitely explain a lot of stuff and know what they do, but answering that question of why gets a little bit trickier. This first one we'd say is very deterministic. In theory, if you give it the same conditions every time, you'll get the same output. These other two work more on kind of probabilities and kind of trying to get something constantly refined better and better and better. These are also the kinds of things you'll be more familiar with in kind of your daily understanding of algorithms when they come up when talking about computers.